So I've wiped out our program, and right now, as you can see, what we've got is our main is just calling ladder 2, and then ladder 2 is just a normal function block that's set up to use ladder logic. So we're going to come in here, and we're going to be working with our single input, which isn't really a physical input, I'm just calling it that. So we're just going to take in1, and we're going to define that as, we'll go ahead and make that global memory and a bool. And I'm going to come down here and give us a few more rungs, and we're just going to put this all right there. So I'm going to put this, what's this called again? Normally open contact here. And we're going to also assign that to in1. And let's put a couple of assignments down. So there's one there, and those are going to be out1 and out2. Why am I into that? Okay, out2, there we go. Let's right click and define that tag. We want to make this global memory, and we want to make these global memory because we're going to be watching these, and you'll see what that means pretty shortly actually. And copy, I'm going to put one more of these here, and now we're going to experiment with our p-trig. So let's just drop that in there. ONS, and we'll define that, and that one we don't need to monitor anywhere, so we'll just make that local static. And let's give ourselves one more assignment, so I'll just paste that in there, but I'm going to change that to out3. And we'll define that one as global as well. And I don't think we'll need that last one, and I am going to use this one. I'm going to skip ahead, and I'm going to use a counter. So I'm just going to drag a CTU over here, and that'll be a single instance. What we're going to be counting is our out3, so let's just define that right there. Our preset value, we'll just put something in there like 10. And we'll store our count value here as out3 count. Right click that, define the tag, and we want to monitor this in a watch, so let's go ahead and make that global memory, and it's an int. Okay. I'm going to come over here to watch and force tables, and I'm going to add a new watch table. And I'm going to start pulling in the things that we need to control and watch. So we know we want our in1. We know we want our outs. So out1, out2, out3. We're going to have our out3 count, and then just for fun, I'm going to go back in here and I'm going to give us one more counter. So let's bring down another rung here, drag over a counter, and this counter is going to be looking at out1. We're going to put a preset value of 10,000 on this, and we're going to store this to out1 count. Right click on out1 count, define the tag. That's going to be global memory int. Okay. Now we can go back to our watch table, and let me show you what it is that we're going to be doing exactly, okay? So back in our ladder, we've got one input that's going to be doing all of the work. Input 1 is going to be directly triggering output 1. So when input 1 is energized and true, output 1 will be as well. Then on the second rung for output 2, we're using this opposite. We're using this normally open. So now when input 1 is false, output 2 should be true. And when input 1 is true, output 2 should be false. Down here, we're controlling output 3. And as soon as input 1 becomes true, output 3 should only become true for one scan. And here we're counting. For every scan that output 3 is true, we should be accumulating those. So each time it becomes true, our output 3 count should go up by 1. Meanwhile, our count for output 1, that as soon as we make input 1 true, that's going to be true for every single scan. So that should fill that count up very quickly. We should hit that 10,000. So now that we've got this, let's go ahead and simulate. I'm going to click the simulate button up here and hit OK. And here we go. We've got our PLC sim up. And I'm sure we're probably compiling the project, looking for errors. I'm sure we're not finding any because this is a pretty simple project to write. If I made mistakes in this, boy, I'm really in bad shape today. Okay, compiling 50%. It's liking it so far. I see a lot of blue on the bottom. Okay, let's load it. And let's tell it to go ahead and start once it loads. Okay, so you saw me set up that watch table. What the heck is that? From a watch table, I can click on the little glasses here with the monitor all. And now when you see monitor value, now I can see what all these actual values are. Also, I can send values in. Now this generally doesn't work for actual physical inputs. Usually for that you want to use a force table. A force table, when I click on that, you see it looks exactly the same, but you can energize and de-energize forces. So you can force inputs to be true or force them to be false, or remove the forces and they'll just be whatever the actual input signal is. But since we're not using physical inputs, we're just using memory, we can do all of that from a watch table. So let's go back into our ladder and we're going to click our sunglasses button here and let's see what's energized and what's not. So input 1 we know is not true. Therefore, output 1 is not energized. Since input 1 is not true, this normally open contact makes output 2 true. So remember, those two will always be in opposition if we're controlling them with the same input using a normally closed and a normally open contact. Here, we haven't energized input 1, so output 3 shouldn't have energized yet. And we can see here the count is still 0. And the count on output 1 is still 0. Watch what happens when we make input 1 true. So we're going to go to the watch table. And right here on input 1, I'm just going to type a 1 there, which represents true. And see this little lightning bolt with a 1? That's going to put in any different values I want to send in and interject. It's going to do that right now. So click, and there we go. So let's come back out here to the ladder. Now you can see that input 1 is true, so output 1 is also true. And because it's true, this normally open contact has made output 2 false. Look, output 3 is not energized. Why is that? Remember, that's a rising edge, that P trigger, meaning that output 3 did become true. You can see right down here our out 3 count has raised to 1, but it only became true for one scan. That was it. And after that, once it came back down, it scanned all the way around the program. Once it came back to here, it became false, and it stays false after that. And look at our output 1 count. The output 1 count, apparently the CTU in step 7 essentially has a one-shot or a rising trigger built into it. So it's not counting every scan. It looks like it's only going to count every rising edge. Let's test that theory. So I'm going to go ahead and come back here, and I'm going to make input 1 false again. And then I'm going to take it right back to true. And sure enough, both of our counts go up.